Hi everyone, my name is Arthur Turrell, and I'm delighted to be talking to you today about economic statistics and stupidly smart artificial intelligence, or AI. Now, I work as an economic data scientist and researcher at the Bank of England, which is a public institution that helps ensure the UK's financial system is on a stable footing. My job at the bank is to use the latest developments in AI and computer science to help us understand the economy better. This helps us to steer the economy so that it can deliver prosperity and ultimately, hopefully, improve our lives. Now, one extremely important way to ensure that we are on the right track with the economy is to look at statistics. And I want to share with you one of my absolute favourite sets of statistics, which was produced by colleagues at the bank working with some academics. So this is a chart of the history of hourly wages over 750 years, worked out in today's money. It shows the remarkable economic progress we have achieved in that time and just how much wealthier we are today than our relatively recent ancestors were. We are very lucky indeed. You can also see where things have gone into reverse from time to time. But for us to take action when that happens, we do need to know about it. And being able to find out what's going on in the economy through statistics is critical. Now, our statistics are currently under some pressure, and this is for lots of reasons. When economists and statisticians started measuring the economy, the UK mostly produced things that were easy to count. Beef, which was easy to weigh, bales of wool, which are easy to count, and ships, which are actually pretty hard to miss, and even by tonnage, they're quite easy to measure. But by 2023, agriculture and manufacturing together only accounted for 9.7% of the UK economy. And today what we produce in the economy is dominated by what are called services. That includes everything from insurance to tourists staying in hotels in the UK to social care work. And these are all much more difficult to count than cows or sheep or even ships. But it isn't just our changing economy that's causing the problem with statistics today. What we found is that in recent years, people are much less willing to answer the surveys that many of our nation's statistics are based on. Information on wealth, employment, population, and lots more is based on surveys. And as survey rates have declined, these statistics have suffered and have given a less accurate picture of the economy. Apart from that, recent years have seen a number of high-profile errors happen in UK statistics, partly because of technology that is increasingly past its sell-by date, and partly because the data that we have available in today's economy hasn't really been matched by improvement in methods. Now, this all presents a big problem because apart from enabling some self-reflection on how we're doing as a nation, many big policy decisions depend on economic statistics. For example, how your school is funded depends on the statistics that are collected across the country. And, just to dig into one example, your school gets extra money if it's considered to be in a deprived area. But whether an area is deprived or not needs to be measured, and partly it comes down to how many people are unemployed in the local area. So measure that number wrong, and your school just might miss out on some funding. So these measurements matter not just for the country, but they actually matter for you and where you live too. Now, beyond government, lots of public institutions and businesses, and even private individuals, also need up-to-date statistics in order to make decisions informed by the best possible evidence. And that's a really big theme of my work at the Bank of England. Now, despite the challenge of creating statistics in the modern economy, there are some very exciting developments. And for me, the biggest is artificial intelligence, or AI, and more generally, the use of computers and a new field called data science to help us with creating, curating, and communicating statistics. But what is AI? Even if you don't think you've come across AI directly, you've almost certainly used it. For instance, when you search on Google, the top result is now generated by AI. When Netflix recommends a TV show to watch or YouTube the next video to play, that is also being provided by AI. Now, most of you will have used ChatGPT or Copilot or other forms of large language models, and again, those are AI. Now, AI is just a very fancy name for an algorithm that does something based on a pattern it sees. For large language models, it's predicting the next word based on having seen an almost unimaginably large number of sequences of words. For recommendation engines, it's suggesting what to watch based on the clips that other people who are a bit like you have also watched. Now, the algorithms behind AI make heavy use of mathematics and computer code, two things that I love. Now, just to give you an idea, here's the code for a ChatGPT style model in the Python programming language. Okay, I hope you're taking notes because there's going to be a test later. So don't worry about the details here. What's going on behind the scenes is a lot of what's called matrix multiplication. Now, you might not have met matrices yet, but they're a bit like vectors, and you'll soon learn about them if you carry on studying maths. But there's nothing really magic here. These models are just multiplying lots and lots of numbers together, albeit in very clever ways. Now, AI can clearly help us decide what to watch next on YouTube, but can it also help us make better statistics? In my mind, the answer is most definitely yes, and I'm going to show you some ways that AI is really smart at doing this. Now, earlier I mentioned how important it is for economists and policymakers to get a grip on the economy. And you can imagine the economy like a big ship that's hard to turn. You want to look out of the horizon and see what's coming. And, we do this with forecasts. These take everything we know about the economy today and try and project it into the future. But just like if you were steering a ship, if you saw an iceberg ahead, you'd want to steer the ship around it. And if you saw calm waters, maybe you'd go full steam ahead. The basic idea is the more warning you have about the future, the better. And of course, predicting the future is especially hard. Now, doing this with the actual economy is in many ways even harder than doing it with a ship. It takes a long time for statistics about the country to be collected, collated, and published. But the freshest possible readings on the country give us the best chance of understanding what might be coming next. So some colleagues of mine and I had this idea to create some news statistics using AI. Our idea was simple. Newspapers cover everything that's happening in the country in real time, far faster than the time it takes to conduct a survey. So perhaps we thought there's a signal in these newspaper articles that we can extract and use to predict where the economy might go next. Now perhaps you can see the challenge here, right? Newspaper articles come in the form of words, not statistics. And that is where AI came in. We used neural networks, a type of AI, to find a pattern that links how people talk about the economy in newspaper articles to what subsequently happened in the economy in the official data when it did come out. We trained up this AI model, and then we were able to apply the same AI model to newspaper text that it had never seen before to get a prediction. Well, we tried this, and this is the chart that we got. So this chart shows the prediction for the growth in the economy, that's GDP, as a percent change 3 months before it happens. So this is our prediction. Well, that red line is the guess 3 months ahead without using newspaper text or AI. The purple line is what the data said when they eventually came out much later. And what you see in the blue line is what the model with AI using newspaper text said. Now you can see that that blue line is much closer to that purple line, even though it's quite noisy. And what this is telling us is that with the right data, you can use AI to help predict the economy. Now, I mentioned earlier that cows don't make up much of our economy anymore, but that's not true everywhere. Argentina is the third largest food exporter and has around 15 million cattle. This is the data on these are currently laboriously collected by surveys. But what if there was an easier way? Well, recently some researchers used a type of artificial intelligence on high-resolution satellite images to count cows from space. The model is called a deep convolutional neural network, and here are some of the results. Okay, now this might not look very much like cows to you, but remember, this AI algorithm has one job, and it's been trained on that one job, and that one job is to see what is a cow and what is not a cow from space. Now, this approach was actually very promising. The average error was just a few cows plus or minus. Now, the win here is that AI can look not just at one image or two images, but at thousands of images a minute, and in principle, it can produce near real-time estimates of the stock of cattle. Whereas a survey would take a long time, it's expensive, the cows get very bored, and it also uses up a lot of valuable time for humans too. Now, you can see how this method could be useful in lots of situations. And indeed, the US Census Bureau, who collect demographic information through surveys normally, has also seen this. They're using satellite images too, and AI, and they're using it to produce new statistics. So these new statistics are on the number and the type of new houses that are being built, from the foundations all the way to when the building is finished. Now, it's not just in space that AI and computer science are helping with statistics, though. They're also helping us to replace those error-prone statistics production pipelines that are based in spreadsheets with much more robust and automated pipelines that use computer code and apply some automatic quality checking. And AI is likely to help play a role in helping people find relevant statistics too. If you think about large language models, you can actually craft them so that they answer questions based on a given fact base, and that they can link back to the data sources that they got those facts from too. And these, will help people find the statistics that are relevant to them more easily. So even with the statistics we've got, we can make them more useful to people. These are all really exciting developments in making statistics serve people better. So I'm thrilled about them. But I want to give you one more example of where statistics actually helped an emergency. And that was when it was during the time of the COVID-19 pandemic. Now, at that time, the government in the UK really wanted to know how fast the virus was spreading, and that meant finding out how much people were moving around. But the situation was changing week by week, far too fast for official statistics to keep up. So my colleagues and I at the Office for National Statistics, where I was working at the time, set up a system that took snapshots of publicly accessible CCTV cameras located all around the country, anonymised them, and then counted up using AI how many people, cars, bicycles, and vans were going past the cameras, and assembled them into new statistics. Now, this gave us an almost real-time measure of human mobility, and we could use that to inform decision-making about how much people were moving around. Now, this wasn't easy because it involved putting 1,500 images through our AI algorithm every 10 minutes. But that's not all. Some of the images were quite difficult from the CCTV cameras as well. So I'm just going to show you this image here. So this is a typical image. Right, so look at the red circle. Do you see a person there, or is it a post? Now, if it's hard for you to tell the difference, it's even harder for AI. And even though it's called artificial intelligence, it isn't really that intelligent. It's only able to recognize the patterns that we tell it to, that it is well used to. And this is why I say that AI is only stupidly smart. Because while it can do some superhuman things like recognize objects in thousands of images, it can only do so if it's had exactly the right training. And unless the circumstances are like what it has seen before, it can easily get confused. Let me show you what I mean. So I'm now going to run an AI live on my computer and pass the video feed through it. And in the best traditions of demos, something's probably going to go wrong. But let's have a go and see if we can do it. So first I'm going to spin up my machine learning algorithm. So that's now running in the background. And now I'm going to switch over my video to get it. Okay, we're just going to resize that so that you can see me properly. That's going to take a second. No one needs to see me up that close. Now, you'll see what's happened here. There's a bit of a delay between what I'm saying and what the video is showing, apart from on the audio. And that's because the data from my video feed has to go through the algorithm. But what you can also see is that it's doing a really good job. With 96% chance, it thinks I'm a person, which is great news. What about we try it on something else though? So what about this? So this is a cup, that's right. And it thinks with about 90% chance that this is a cup. So it's doing a pretty good job. Let's try something else. Let's try a book. And let's try a book that is familiar to people working on AI and machine learning everywhere. It's The Elements of Statistical Learning. So AI, is this a book? Yeah, it's a book with about, again, 90% probability. So this algorithm is really, really smart in some ways, but I'm now going to show you how it's only stupidly smart. So if I hold up this notebook on which I've drawn a picture of a balloon, we'll see what it said it is. I'm just going to back off a bit. Oh, okay. Was that a refrigerator? A knife? A knife or a refrigerator? I mean, it could be either, really, couldn't it? Let's turn off our AI algorithm now and go back to the normal camera. So what we saw there was that as we start to use AI to better understand our world, we do need to be careful at the same time as taking advantage of its incredible power. I like to think of it a bit like a mischievous genie. You have to be very careful what you ask it for. And if you're sensible in your questions, then you'll get what you wanted. But if you're not careful, then you might get a refrigerator instead. Okay, so today I've taken you on a tour of how important economic statistics are for the decisions we make about society, how they're under some pressure, and how AI can help. It's an exciting time to be working on this area of bringing the developments in computing to bear on the big statistics challenges of the day. Although we've just seen that there are pitfalls too, as well as a lot of potential. Now, as if the opportunity to work on better measurement wasn't enough to excite you, I want to leave you with an even bigger reason to get into the world of statistics and AI. The opportunity to win literally millions of dollars. Now, in 2024, there were hundreds of AI competitions that combined often around $20 million, that's £15 million in prize money. So, for example, the US Bureau of Reclamation, who manage water resources, funded a series of competitions with a total of $500,000 in prize money for predicting the supply of water. And it looks like there's going to be even more money on offer in the next few years. Some of you, for example, may be familiar with the International Mathematics Olympiad. Now, there's a prize of $5 million open currently for the first AI model to get the equivalent of gold at one of those Olympiad tests. But by far my favourite of these AI challenges that come with money is the Vesuvius Challenge. Now, that's an AI competition that aims to read the scrolls that were buried and carbonised by the eruption of Mount Vesuvius in 79 AD. These scrolls are so delicate that they can't be unrolled. You can't just pick them apart because they crumble. They've got to be scanned remotely by remote sensing techniques. And then the challenge is to use these remote sensing techniques to digitally unroll the scrolls and make out what the writing is. Now, the challenge has already awarded about $1.5 million for work conducted so far, but it's offering hundreds of thousands of dollars more for using AI to read full scrolls using these 3D scans of the insides. Now, I'm most excited about this one because no one has read a word of these scrolls in 2,000 years. You could be the first in 2 millennia to read them and, unlock who knows what secrets about the Roman world from that time. And who knows, the next competition might just be to create new economic statistics using AI. I'll certainly be looking out for that. So whether you're a person or a post, I think that's a pretty exciting trend. Thank you for listening.